Hello, and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for some Monday musings. During the late Ordovician period, there was a sudden cooling event caused by the rapid expansion of glaciers, resulting in one of the most severe glaciations of the Phanerozoic, an extreme cooling event generally believed to be coincident with the first pulse of the late Ordovician mass extinction, of which I have mentioned previously, but we're going to talk about more today. Now, this rock formation here, known as the Bighorn Dolomite in Wyoming, shows strong evidence of glaciation from this period. The sequences of the Bighorn Dolomite display systematic changes in their component cycles, and the changes in these cycles are interpreted as being a change from a greenhouse climate to a transitional icehouse climate, which are two very different things. There is one paper from 2012 by Holland and, I'm so sorry, this is Polish, and I'm not sure I can pronounce it right, but I'm going to try, Paczkowski, which states that isotopic evidence suggests slow ice cap growths at the poles. The different layers in the members show a cyclic change from greenhouse to icehouse conditions as well. So that's where we've got our idea. Now, this glaciation coincided with the second of the 5 mass extinction events that have occurred. The extinction event consisted of 2 phases. The first phase of the extinction is thought to have taken place because of the rapid cooling and increased oxygenation of the water column. Now, you'd think that more oxygen wouldn't be a bad thing, but just like you can die from water poisoning if you drink too much water, there can be problems with too much oxygen too. This was the larger of the 2 phases, and it caused the extinction of most of the marine species that existed in the shallow and deep oceans. The second phase of the extinction was associated with a strong sea level rise, and due to the atmospheric conditions, namely oxygen levels being at about 50% below today's levels, high levels of anoxic waters were common. It's pretty tough for most organisms to survive without oxygen. Just in case you were wondering, most need that. So in total, the late Ordovician saw a loss of 85% of marine animal species and 26% of animal families overall. So pretty big extinction. But what caused this glacial period? We don't really have a concrete answer yet. Many scientists are still trying to figure out what happened. Here are a few ideas that they have come up with. So the first is that there was depletion of atmospheric carbon dioxide. Methods for how this occurred are still pretty hotly debated. Asteroid impact. As mentioned last Monday, a series of meteorite impacts from a ring of rock debris around the Earth happened prior to the start of the glaciation and could have had a hand in helping start it. Volcanic aerosols could have blocked out the sunlight. I mean, heck, just that single Mount Pinatubo eruption, not Pinatubo. Yeah, no. My mind is drawing a blank on which volcano, but there was that one volcano in the 1800s, early 1800s, that went off and caused a mini ice age, sort of. It made the northern hemisphere very, very cold and caused a lot of crop failure and a lot of deaths. So if there was like a large volcanic province that was forming, which we don't have any evidence of as of right now, doesn't mean it happened. It could, I don't know. As far as we know, didn't happen, but if it did, it could have put enough aerosols into the air to block out the sun and cause some problems. Another idea is that a drop in sea level allowed for more land for ice formation and growth. There's thought to be some evidence that sea level started to drop before the glaciation started. So maybe. And then finally, paleogeography. Basically, the position and the size of the continents influence climate. We know this. So if they were in just the right spot at just the right time with just the right tilt of the Earth and all of this stuff, it could have caused a glaciation. Now, it's likely that all of these had some part in the extinction event and the consequent end of the period and start of the Silurian. But, like I said, it's still in the works. We're still trying to figure out exactly what went down. So, as of now, it could be any of those things. So, what do you think it was? Tune in tomorrow and see if you can pass the geology quiz. Woo! And I will fossilize you later.